Use discrete convolution to find the response to input x of n is equal to a raised to n un of the LTI system with impulse response hn and equal to b raised to n u of n. Problem based on the convolution. So first we write here what is given. So given x of n is equal to a raised to n u of n and h of n is equal to b raised to n u of n. Now sequence xk and hk. And h of k can be written as x of k is equal to a raised to k u of k and h of k is equal to b raised to k u of k. Now we have the definition of linear convolution. So according to linear convolution, y of n is equal to k tends from minus infinity to infinity x of k into h of n minus k. This is our equation 1. Now we have h of k is equal to b raised to k u of k. This is equation number 2. So sequence which h of n minus k is obtained by replacing k by n minus k in equation 2. So equation 2 becomes h of n minus k is equal to b raised to n minus k u of n minus k. So now equation 1 becomes thus. Equation 1 becomes y of n is equal to summation k tends from minus infinity to infinity a raised to k u of k into b raised to n minus k. We replace this value of h of n minus k, b raised to n minus k u of n minus k. So y of n is equal to summation k tends from minus infinity to infinity a raised to k b raised to n minus k into u of k into u of n minus k. We just rearrange this equation. So this is equation number 4. Now the sequence u of k, it is a unit step. So we write here sequence u of k is unit step. So while u of n minus k is equal to u of minus k plus 8, it indicates delay of u of minus k by n, delay of n samples. So we draw the diagram for these sequences. So first it is k, u of k having values so it is 1 1 1. Next step is folding. Folding means reverse, so it is 0. It is u of minus k is equal 1 1 1 1. So it is 1. So this is the sequence for delay by n. This is u of k minus k plus n sequence. This sequence is for u of n. So above is the sequence of u of n minus k. Now the next part is product of u of k and u of n minus k. So first we draw here u of k. This is k. U of k is this one. Okay, so we'll draw it. U of k. One. Okay. And this is minus 1 minus 2. Now multiplication with u of n minus k. So it is, this is k, u of minus k plus n or n minus k. It is dot dot 1 1 1 dot dot 1. So it is 0 1 2 3 so this is 0 to this is 0 to n. This is n dot dot dot. So product of both these, the answer is this is k, this is u of k dot u of minus k plus n. It is 0 0 1 1 1 dot dot 1. This value is at x of 0. One. So this is a product of u of k and u of n minus k. Now this multiplication, that is which multiplication, that is u of k dot u of n minus k, it indicate the sequence is present only for the range 0 to n. So indicates sequence is present only for the range 0 to n. So we change the limits of the summation in equation 4. So we change limits of summation in equation 4. Now the new limits will be k will be from 0 to n. So y of n is equal to summation, value of k goes from 0 to n, a raised to k, b raised to n minus k, u of k dot u of n minus k. But what is u of k dot u of n minus k? It is, so y of n is equal to summation k changes from 0 to n, a raised to k, b raised to n minus k. Now what is, we split this term, that b raised to n minus k is nothing but b raised to n into b raised to minus k. So we can also write b raised to n divided by b raised to k. So above equation will be yn is equal to summation k goes from 0 to n, a raised to k, and here b raised to n divided by b raised to k. Here summation is in the terms of k, so we take this b raised to n outside the summation sign. So it is b raised to n summation k changes from 0 to n, a raised to k divided by b raised to k. So we can also write yn is equal to, it is a by b bracket raised to k. Now we use the standard equation of the summation. So we use standard equation of summation. So it is summation a n, it is a raised to n 1 minus a raised to n 2 plus 1 divided by 1 minus a. This value is for a not equal to 1, and for other it is n2 minus n1 plus 1, where for a is equal to 1. This is equation 9, this is equation 8. So this is equation 8 and this one is 9. So we compare equation 8 and equation 9. We write here, compare equations 8 and 9. So here n1 is equal to 0, n2 is equal to small n, and a is equal to a by b. Therefore y of n is equal to b raised to n a by b by this is for a by b not equal to 1. So our final equation is This is your final equation. Okay. Next, obtain linear convolution of two discrete time signals given as xn is equal to un and hn is equal to a raised to n un a less than 1. Now what is given? Given is xn is equal to un, that is unit step. This is unit step signal, and hn is equal to a raised to n un, this is exponential signal. So we write here, given x of n is equal to u of n, that is unit step signal, and h of n is equal to a raised to n u of n is an exponential signal. So here an is exponential signal and it is multiplied by u of n. So we know that u of n is present only for positive values of n. So we write here, we know that u of n is present only for positive values of n. That means from n is equal to 0 to n is equal to infinity. So this multiplication indicates that a raised to n is present for positive values of n. And it will not affect magnitude of a raised to n, because magnitude of u raised to n is 1. So we draw the sequence for this. This is n, this is a raised to n, u of n, a raised to 0 is 1. So this is exponential sequence. This figure shows exponential sequence a raised to n. Now we write the equation of convolution. So equation of convolution is y of n is equal to summation k tends from minus infinity to infinity h of k into x of n minus k. X of k. Yn is equal to summation k tends from minus infinity to infinity x of k into h of n minus k. This is equation 1. Now in this equation h of n minus k, it is delayed by h of k, that is by k values. So instead of that we can delay x of k and keep hk as it is. So here right here h of n minus k is delayed version of h of k. So instead of that we can delay x of k and keep h of k as it is. So the equation will be y of n is equal to summation k tends from minus infinity to infinity h of k into x of n minus k. So this is equation 2. Now which property this is? This is a commutative property of the convolution. So we write here this is commutative property of convolution. So we use equation 2 here. Okay. Now we have the generalized expression for the convolution for finite sequence with an infinite sequence. So we write here we have generalized expression of convolution for finite sequence with an infinite sequence So this equation is y of n is equal to x of 0 u of n plus x of 1 into u of n minus 1 into x of 2 into u of n minus 2 plus dot dot dot. This is our equation 3. Now when both the sequences are infinite, then when both sequences are infinite, then equation 3 will be y of n is equal to x of minus 2 u of n plus 2 plus x of minus 1 u of n plus 1 plus x of 0 u of n plus x of 1 u of n minus 1 plus x of 2 u of n minus 2 plus dot dot dot. This is equation 4. Now here xn is some infinite sequence. Here x of n is some infinite sequence and h of n is equal to u of n. Now equation 4 is based on equation 1. So in this case input x of k. In this case input x of k is kept as it is and h of k is delayed. But if we use equation 2, Then linear convolution is, we write here, if we want to use equation 2 to obtain linear convolution, then y of n is equal to h of minus 2 u of n plus 2 h of minus 1 u of n plus 1 plus h of 0 u of n plus h of 1 u of n minus 1 plus h of 2 u of n minus 2 plus dot dot. This is equation 5. Now equation 5 we are taking xn is equal to un. So in equation 5 we are taking x of n is equal to u of n, and given equation of h of n is h of n is equal to a raised to n u of u n. This is equation 6. So h of n is equal to a raised to n, and it is 0 for n greater than equal to 0 and for n less than 0. Now sequence h of n can be written by putting values of n in equation 7. So this is 7. Now that is for n is equal to 0, h of n is equal to h of 0 is equal to a raised to 0 equal to 1. Now n is equal to 1, it is h of n is equal to h of 1 is equal to a raised to 1 is a. Now n is equal to 2, hn h of 2 a raised to 2, n is equal to 3, h of n h of 3 a cube dot dot. So h of n is equal to 1 a square a cube dot dot. This value is at 0. So this is equation 8. Now putting values of hn in equation 5, we put these values, put values of h of n in equation 5. Now equation 5 we get y of n is equal to 1 into un plus a u of n minus 1 plus a square u of n minus 2 plus a cube u of n minus 3 plus dot dot dot. So the previous equation is equation number 9, and this equation, that is equation 9, gives convolution of given sequence. So to calculate the sequence yn, to calculate sequence y of n, put different values put different values of n in equation 9. So y of 0 is equal to u of 0 plus a u of minus 1 plus a square u of minus 2 plus a cube u of minus 3. So here u of 0 is 1, u of minus 1 is minus u of minus 2 is it is all equal to u of 0 is 1, u of minus 1 is equal to u of minus 2 is equal to u of minus 3 is equal to 0. So y of 0 is equal to 1. Now put n is equal to 1 in equation 9. So put n is equal to 1 in equation 9. So the equation will be y of 1 is equal to 1u1 plus a u of 0 plus a square u of minus 1 plus a square u of minus 2. So here u of 1 is equal to u of 0 is equal to 1 and u of minus 1 is equal to so y of 1 is equal to 1 plus a. Now put n is equal to 2 in equation 9. So it is y2 is equal to u2 plus so what is the value of y of 2? It is equal to 1 plus a square. Similarly, for nth sample, y of n is equal to 1 plus a plus now we can write in terms of equation. This is equation 10. Now we write here so this is equation 11. Now we use standard equation of summation. So this is the standard equation of summation. Now in given example or in present example, so from equation 11, what is n1? n1 is lower limit of summation, which is 0, and what is n2? upper limit of summation, which is n. Now put these values in standard equation. Put these values in standard equation 12. So y of n is equal to a raised to 0 minus a raised to a plus 1, 1 minus a. So it is yn is equal to minus a raised to n plus 1 divided by 1 minus a. Thank you.